Problem number 3 reads, a tennis ball is dropped from a height of 2 meters above the court. It rebounds to a height of 1.2 meters on the first bounce. How much energy is lost to heat on the bounce? The mass of the ball is 60 grams. Let's take a look at that ball. The tennis ball is released from a height of 2 meters above the court, falls, bounces, but loses energy to heat on the bounce, and rises to a height of only 1.2 meters. And then, on subsequent bounces, loses even more energy. Given that information, that it is released from a height of 2 meters, rebounds to 1.2 meters, and that the mass of the ball is 60 grams, you are to find the heat lost on that first bounce. Turn off your VCR at this point and try to solve this problem before watching its solution. The tennis ball is pictured at point 1 at a height of 2 meters above the court and at point 2 at a height of 1.2 meters above the court. The sum of the kinetic energy at point 1 and the potential energy at point 1 is equal to 0 for the kinetic energy because the ball is momentarily at rest, plus the mass of the ball times the acceleration of gravity times h1. If we calculate that, we have the mass of the ball, 60 grams, and in kilograms, 0.06 kilograms. 0.06 kilograms times the acceleration of gravity, 9.8 meters per second, multiplied by the height, 2 meters, gives 1.18 joules. If we calculate at position 2, the kinetic energy at position 2 plus the potential energy at position 2, we get again for the kinetic energy 0 because the ball is again momentarily at rest at position 2 plus the mass times the acceleration of gravity times h2. And if we put in the numbers for that, we have that this is equal to 0.06 kilograms times 9.8 meters per second times 1.2 meters, and that gives a value of 0.71 joules. So this sum of kinetic and potential energies at these 2 points is different. And the difference between these two sums simply represents the heat that is lost on the bounce. So the heat we find by taking the difference, 1.18 joules minus 0.71 joules, and that difference turns out to be 0.47 joules. That's the heat lost. That's the solution to our problem, a fairly simple problem. Before moving on to problem 4, we are going to look at a brief review of the conservation of momentum.